On paper, everything was correct. The specified torque was achieved, production moved on, and nobody suspected a thing. Then, bam, unexpected movement, instability, downtime. Suddenly, everyone's asking the same question. If the torque was correct, why did the joint fail? It's a bigger problem than many people realize. Manufacturers spend around 6% of their annual revenue on quality assurance, with roughly 5% of those quality costs dedicated to torque-related issues. Yet failures still occur.
That doesn't make sense. If the torque was correct, what went wrong?
Welcome to Inside the Joint, Episode 1, where we're answering exactly that question.
So where do we start?
We start by understanding one simple fact. Torque isn't actually what keeps a joint together. Torque is simply the turning effort we apply during tightening. Think of closing a jar. You know how hard you turn the lid, but not how tightly it's actually sealing. Torque measures the effort, not the result.
So if torque isn't the objective, what is?
Clamping force. That's the force squeezing the joint components together after tightening. It's what prevents movement and allows the joint to carry loads safely throughout its life. Think of holding a stack of papers. The harder you press, the less the sheets can move.
So clamping force is what actually keeps the assembly together?
Exactly.
And how does a bolt actually create that force?
To generate clamping force, the bolt actually has to elongate, acting like a spring.
Wait, really? A spring? It's a solid piece of steel.
It is, but when you tighten a bolt, you're stretching it. As it tries to return to its original length, it continuously pulls the joint together, generating clamping force. Think of stretching a rubber band. As it tries to return to its original shape, it pulls back. A bolt does the same thing, only by a tiny amount.
So does that stretching have a name?
Engineers call it preload. It's the initial tension created in the bolt during tightening. That tension generates the clamping force holding the parts together before the joint sees any operating loads.
So they're both deforming?
Exactly. Think of it as two springs working together. The bolt is stretched in tension while the joint is compressed as it's squeezed together.
What happens when an external load tries to pull the joint apart?
The load isn't transferred entirely into the bolt. Instead, it's shared between the bolt and the joint.
So achieving the correct preload doesn't guarantee the same clamping force during operation.
Exactly. The actual clamp force during operation depends on the external axial load acting on the joint. If those loads become large enough, the clamp force can eventually drop to zero.
And once that happens, the joint begins to separate.
Exactly. The parts are no longer being pressed together, and reliability can deteriorate very quickly. That's why achieving preload is only the first step. Maintaining sufficient clamp force throughout service life is the real challenge.
If clamping force is so important, why don't we measure it directly?
Because direct measurement on a production line is usually difficult and expensive. That's why most manufacturers use torque as an indirect estimate.
If torque is only an estimate, what determines how much clamping force we actually get?
Friction, lubrication, and surface conditions all affect how much of the applied torque is converted into preload. A large portion of the torque is simply lost to friction.
So two bolts can reach the same torque value but end up with different clamping forces.
Precisely. Torque is useful, but it's only an estimate of what's actually happening inside the joint. That's why verification becomes critical. What we apply during tightening isn't necessarily what remains in the joint over time.
Though if there's one thing to remember from today's episode, it's this. Torque is the turning effort, but clamping force is what actually keeps the joint together.
Exactly. Clamping force is the real objective.
And in our next episode, we'll introduce an important concept in bolted joint quality control, the joint check, and specifically what residual torque really means.
Because once a joint has been tightened, the key question becomes whether the required clamp force is still there. Residual torque is one way to assess that.
Stay tuned for the next episode of Inside the Joint.